Today we're going to talk about nutrition and the role it plays to keep astronauts healthy on the International Space Station. Hi, I'm NASA astronaut Tracy Dyson. Welcome to StationLIFE.
Houston on 2 for velocity calculation, station assembly, steps 45 and 46. We're moving on to step 5.
You will go right now for that activity.
Copy, thank you.
Okay, Tracy, we copy, and that's good information. We'll pass it along.
Good nutrition is a part of good health, whether you're on Earth or off. Today's show will focus on nutrition research aboard the International Space Station. That's one small bite for man, one giant leaf for mankind. Astronauts Scott Kelly, Kjell Lindgren, and Kimya Yui of Japan recently sampled the fruits of their labor after growing and harvesting a crop of outrageous red romaine lettuce from the Veggie Plant Growth Facility. This was the first crop of vegetables grown in space, specifically for the purpose of providing fresh vegetables for the astronauts. Later this month, the crew will harvest zinnia flowers, a precursor for the next crop. We're going to try tomatoes. You know, living in space changes our bodies in a number of ways. We lose bone mineral density, our muscles atrophy, our cardiovascular system gets weaker, and we experience immune system dysfunction. One of the ways of understanding the changes in our bodies during long-duration spaceflight is to study our nutritional status at specific time points during our mission. Samples that we collect while we're in space provide scientists with information on bone metabolism, oxidative damage, body chemistry, and hormonal changes. These insights give scientists a more complete picture about what's happening in our bodies. That increased understanding of the role of nutrition in adaptation to spaceflight has a broader application on Earth. One example is understanding the relationship of nutrition to bone loss. This is potentially valuable for people suffering from osteoporosis right here on Earth.
The bones in our bodies are alive, growing, and changing all the time. Our bones are composed of different layers. The outer surface of bone is called cortical bone. This is the smooth, hard part of the bone that we can see when we look at a skeleton. Inside the cortical bone is the trabecular bone. This type of bone looks like a sponge and helps to protect the bone marrow. The constant process of bones growing and changing is known as bone remodeling. This process is carried out by specific cells in our bones. Cells called osteoclasts have the role of breaking down our bone and removing any parts that need replacing. At the same time, cells called osteoblasts have the job of making new bone and helping to repair any parts of the bone that have been damaged. On Earth, in healthy individuals, this process is normally balanced so that the same amount of bone is made and broken down. In space, astronauts are exposed to lower levels of gravity than on Earth. This means that they have less mechanical stress put on their bones as they move around. Scientists believe that the bones naturally try to adapt to this new environment by increasing the rate that the bone is broken down by the osteoclasts. Meanwhile, bone formation continues to occur at the same rate as it does on Earth. The result is an imbalance in bone remodeling, which leads to an overall decrease in bone mineral density. While in space, astronauts can manage with lower bone density, but when they return, their bones are less able to cope with Earth's gravity. This increases the risk of fracture and injury. Scientists use many different tests to measure the density of the astronauts' bones. Results show that the astronauts, while in space, lose bone in a similar pattern to people on Earth who suffer from osteoporosis, but the astronauts lose it at a much faster rate. Scientists have found that exercise, when combined with good nutrition and increased vitamin D intake, is able to preserve some of the bone that was previously being lost. Since 2008, astronauts have been able to use a new exercise machine called the Advanced Resistive Exercise Device, or ARED. It is thought that this increase in force triggers the formation of new bone, bringing more balance to the bone remodeling process and allowing the bone density to stay at roughly the same level as it was before the spaceflight. It is a significant achievement to be able to maintain bone density in space, but more experiments need to be carried out to see whether the new bone which is formed in space has the same structure and strength as new bone which is formed on Earth. Understanding bone loss associated with microgravity may lead to better preventive care or therapeutic treatments for people on Earth suffering bone loss as a result of bone diseases like osteopenia and osteoporosis, or for patients on prolonged bed rest.
One of the things I love about the field of nutrition, one of the things that really drew me into the field of nutrition as a graduate student, was the fact that nutrition really is a cross-cutting science, and the fact that we get to look at all the systems and nutrition in and of itself. So doing bone studies and muscle studies and vision studies and cardiovascular studies really helps to branch out and to work with other groups and see the integration within the human being, and not just focused on a specific enzyme in a specific tissue in a petri dish in a lab somewhere in a basement. One of the great things about nutrition research on Space Station is that Space Station is a great platform, and that it allows us to study very healthy individuals in a very strange environment, in a very unique environment that the body is trying to adapt to. And what that does, that allows us to understand how the body responds to these changes, and in many ways that reflects disease patterns or altered physiology, if you will, on Earth. So bone is a great example where when an astronaut is put into spaceflight, the body starts to break down bone because the body realizes it doesn't need the same skeleton in weightlessness as it did on Earth. And by looking at that adaptation and how to counteract that adaptation, that tells us about how the body responds to these different changes. So we see roughly the same change in bone in about 6 months on a space station mission as you would see in a much longer period, 4 or 5 years. So it's almost like time-lapse photography where we can see a much faster glimpse of what's going on. We can study countermeasures much more quickly. And again, the implications of those studies for people studying those same phenomena on Earth really helps to leapfrog some of the technology ahead. Hi, my name is Scott Smith. I'm the lead for the Nutritional Biochemistry Lab at the Johnson Space Center, and we're studying nutrition off the Earth for the Earth.
In space and on Earth, our bodies require proper nutrition. Defining the nutrient requirements for spaceflight and ensuring provision and intake of those nutrients are primary issues for astronaut health and mission success. After all, you are what you eat. One challenge is providing appetizing food for astronauts that doesn't require refrigeration and has a long shelf life. While the food is generally much better than you might imagine, and we have come a long way since the early days of spaceflight, we do have limited access to fresh foods. In our next segment, we'll go inside NASA's Space Food Systems Laboratory, as seen in the National Geographic Space Station Live program.
Eating in space is its own kind of fun. But keeping astronauts fit and healthy is a serious business. Michelle Clinch is responsible for what they eat.
We're making spaghetti with meat sauce.
Space meals begin just like ours do, with a trip to the supermarket.
Thank you.
But the similarities stop there. Spaghetti and meat sauce is just one of the 250 things on the space station menu. Each portion is meticulously calibrated.
We have a database where we maintain the nutritional content of all our products, calories, fat, protein, carbohydrate, things like that.
But the most important calculation is what things weigh. That's because it costs $10,000 for every pound blasted off to the astronauts. So NASA adopted a reduction technique, also used by the military.
Freeze drying removes a high percentage of the moisture, so typically when we freeze dry our products, we take them down to about 3%.
Each portion now weighs just 1 ounce. Cost to transport, $660. 1,300 miles away, and the orbital Cygnus resupply module is being loaded with the freeze-dried food. And it's time for a few last-minute food luxuries.
These are the tortillas. They're very popular on orbit.
After a daily routine of freeze-dried meals, a fresh piece of fruit is a welcome relief, well worth its weight in gold.
As you can see, we're only sending 3 apples, so you may think that's unfair because we have 6 people on orbit. They may have to share.
This very precious cargo is one of the last things to be loaded onto the rocket.
It's on its way.
3, 2, 1.
Less than a kilometer away from us now.
2 days later, Cygnus docks with the space station.
We're getting ready to berth the Cygnus 1 vehicle. All right. Looks really good. Perfect. Perfect. All right. Bonus food.
Including some surprise treats from their families.
Wow. Oh, look at that. Tortilla. The real tortillas. Look at that. Real tortillas. Pours it. Wow. Oh my goodness gracious. The greatest hot dog relish in the history of man. Oh my gosh, my wife didn't tell me about this.
Hello, and welcome to Node 1. In the boxes you see here, we keep our food on the International Space Station, and specifically the food that we are currently eating. And in our logistics module, Leonardo, where I was just now, we keep our supplies. We keep them in soft containers like this one, which we call bobs. And this one is a very special bob for me because it contains my bonus food, the food that I chose myself based on my preference and my taste. This one, for example, is one of my absolute favorites. It's quinoa salad with mackerel. Mackerel is a great source of healthy proteins, but also of healthy fats. Those fats that our body absolutely needs to stay healthy and in good shape. On board we have different kinds of fish, which are great sources of healthy fat. For example, thanks to our Russian colleagues, we have sturgeon. In my bonus food, I also took sources of healthy fats that I can eat for a snack. I love avocado, for example, so I took it in form of guacamole that I can spread on my bread. Or I also love dry fruit, so I have almonds and nuts. And I didn't forget to take olive oil. And I can tell you, our rehydrated veggies not only taste a lot better with olive oil, but they're also a lot healthier. So I hope you will put the right rocket fuel into your body, starting with the right types of fat. And remember, eating healthy is not rocket science.
You know, I don't know the reason behind it, but your taste buds change when you get to space. So the things that you like on Earth and you just can't get enough of, you've got enough of when you get to space. So there's something about your taste buds. Don't know what it is. However, aromas, you don't get enough of it, partly because of the way things are packaged. And coffee, for instance, has this smell that you kind of consume while you're eating the food, but it's in a package that has a straw and you can't smell anything. So it still didn't stop me from drinking it, but you just couldn't smell it. And same with all the other foods. They come in a little package, and so you don't really smell it very well. And you miss that. When you come back to Earth, you find out just how important smell is when you're eating food. So, how does the space station smell? You know, this is a good question because in general, the space station smells like nothing. It's clean, except if you're in node 3 and you're working out on the ARED machine and all of a sudden you smell something that you think is coming from the WHC, but it's actually, which is our space potty, but it's actually our Russian colleagues back in the service module open up a can of beef, and it gets into the air circulation system, and it makes its first stop in node 3. And so at first you're like, oh, what is that? And you're like, oh wait, it's lunchtime. And then it's a much better smell into your brain. You know, mealtime in space can be a lot of fun. It's especially dinner time. At the end of this long day where 6 people, 6 little pink bodies in space, working all day long, and we're rarely together working unless it's something very unique. We're all off doing our own thing. And to come together at the end of the day when you know that you've signed off with mission control and you're in that evening period of time, that you can sit around a table with your crewmates and share food. And when you're an international crew and you have food from your Russian crewmates, your Japanese crewmates, well, that's what we are, crewmates. When you have everybody coming together at the table to share their food, that's one of the best parts about eating in space.
So I just finished eating and I have to enter in what I ate because the ground folks like to keep track of it, keep calories, how much salt we're getting, how much protein, things like that. They track us closely on everything. When we lift weights, we have to keep track of how much weight we lift, how many reps we do. When we run on the treadmill or when computers are recording our heart rate, when we turn on lights, when we turn on the toilet. I learned on my first mission there are no secrets in space. We got video cameras in just about all the modules. So it's basically like being in a big fishbowl. The ground knows everything about us up here, which is not that big a deal, but it's something to keep in mind when you need a little privacy.
I'm just getting my safety cutter on the other side of my IDA back here. Copy, Terry. A lot easier without the pool stanchion.
Absolutely, yeah. And it's just like in the pool instead of that, with the exception of that big blue planet down there.
Exactly.
As the International Space Station flies 257 statute miles over the coast of Chile, Terry Virts in the initial moments of his first spacewalk.
Welcome back, and thanks for watching this episode of Station Life. As you can see, space station nutrition research is vital towards improving the quality of human health and well-being in space and here on Earth. NASA is constantly searching for ways to benefit humanity, as together we take the next steps towards exploring our universe, searching for the answers that matter to us the most. Thank you for joining us on Station Life and our behind-the-scenes look at nutrition research aboard the International Space Station. Be sure to stay in touch and follow us on Facebook and Twitter for the latest research news. And don't forget to download our fabulous app on your mobile device. Until next time, stay with us, off the Earth, for the Earth. I think it's time to eat.